Yes, good morning guys to all of you. Please tell me, am I properly audible and visible to all of you or not? So guys, today is a very important session, as today we are going to see the formulas of theory of machines, vibration and machine design. Okay, so this session is very important because guys, you know, theory of machine is a subject which is having very high weightage. Kartikeya, good morning dear. So just like and share the session guys, so that others can also join. So I welcome you all on this wonderful platform, that is Byju's Exam Prep. Yes, Shreyas Negi, good morning dear. Fine. So guys, we are starting. So today we are going to have the formulas of theory of machines. Okay. So we will try to cover machine design also. But if it is not going to be possible, then we will be having one more session for machine design. Okay. So we will have a target of Tom plus MD. Utkarsh, good morning. Venkatesh, good morning. Yes. Anantal Sharma, good morning. Yes. So guys, we are starting the session. So this is some detail about me. I am having around 10 plus years of experience, written many research and review papers. And these are my areas of expertise. And today's subject is theory of machines and machine design. Okay. So Utkarsh, I feel this is YouTube English channel. Here we are having theory of machine session. Both channels have different schedules. Okay, so don't mix up both the channels. Okay, so this channel is different, that channel is different. So guys, this is the Telegram channel link, Mechanical by Dheeraj Sardana. If you will be joining it, you will be getting the PDF of this session and all the sessions. You will also be getting that handwritten notes of different subjects. And also you can ask any doubt related to mechanical engineering there. So this is going to be the benefit, and all exam notification will also be there. So guys, on 1st of November, there is a free workshop at 8 PM related to 5 tips to boost score in the mock test. So guys, will be taken by Fanendra sir. You can register for free by going into description box for the same. Yes, Abhijit, good morning. Mani, good morning. So we are going to start the session now guys. Okay, so guys, as I said, this is a formula revision session, but I have kept some concepts also to make it more interesting, because if I would be just showing you formula, it may become boring. So guys, I will also be dealing with the concept. So Saurabh, good morning dear. So guys, first of all, we are talking about the first chapter, that is simple mechanism. And I already told you many times, whenever something coming for the first time, then for that we are using this word simple. So my dear, the point is, in this chapter we are going to reach to the very first mechanism which came into picture. Okay, so the very first type of mechanism which came into picture we are going to deal with. So guys, for reaching up to mechanism, first of all we need to talk about kinematic link or element. I also told you, like, simple gear train is the very first type of gear train came into picture. So whenever something comes for the first time, like simple harmonic motion was the first type of harmonic motion. Okay, so simple spur gear was the first type of gears. Okay, so guys, now we are talking about kinematic link or element. So as I said, generally whenever we are talking about a machine, this machine is made up of a number of parts. So the smallest part of a machine which is having relative motion with respect to some other part is said to be kinematic link or element. So whenever we are using this word, this is every part of machine which is having some relative motion with respect to other part is said to be kinematic link or element. Whenever we are saying the word kinematic link, generally what student feels? Student feels that kinematic link is going to be some rigid body, but it is not true. A link may be a rigid body, may not be a rigid body. Some people think relative motion and absolute motion, they have no clarity about that. So guys, there is a difference between absolute motion and relative motion. Like, let us say when we are having this person, okay, and this person is moving with 10 meters per second with respect to a person who is sitting ideally. So he is having velocity 0. So according to him, he is moving with 10 meters per second. This is absolute velocity. But my dear, if this second person is moving with 5 meters per second, so according to this person will be moving with 5 meters per second. So that is relative motion. So if you say that this is A, this is B and this is C, then velocity of A with respect to C is the absolute velocity of A, which is 10 meters per second. Okay guys, and when we are saying velocity of A with respect to B, this is relative velocity and this is 5 meter per second. So my dear, if let us say there is another person D and that D is moving with the 10 meter per second, then according to D, A will be at rest. So this is said to be the relative motion. Yes, and A, good morning, Bidun, good morning, Sachin, good morning. Yes. So my dear, when we are talking about this, this is the concept of relative motion and absolute motion. So as I said, for kinematic link, relative motion is required, absolute motion may or may not be there. Okay. So like when you see a lathe machine, in lathe machine, the lathe bed is always at rest and the components which are chuck is rotating, cutting tool is moving. So movements are there of the component, but lathe bed is at rest. So my dear, as I said, lathe bed absolutely is at rest. But when you will be sitting on the chuck and you will see the lathe bed, you will feel lathe bed is moving, because as I said that relative motion and absolute motion are different. So for kinematic link, relative motion is required. So as I said, relative motion is required. So second point is link may or may not be a rigid body. It may or may not be a rigid body, but it must be resistant body. Now what is the meaning of resistant and rigid? I would like to tell you in very small. When we are talking about a rigid body, then rigid body means deformation is zero, stiffness is infinite. So rigidity is not required, but resistance should be there. What do you mean by resistant? So my dear, resistant means it must be capable of transferring the motion. So as this is a revision session, so I am not going to repeat the stories you have listened in the full length classes. Here I will be just giving you a revision. So here those stories would not be there. Those were required to make the class interesting. Okay. So this is a revision session. So transferring of motion is possible. So for that, body should be resistant. So guys, now we are talking about the types of link. There are three types of link. One is rigid, other is flexible, third is fluid. So my dear, if we have the deformation which is nearly equals to zero, or you can say it is negligible, such kind of links are said to be rigid link. Crank, connecting rod, cylinder, piston, they all are the example of rigid link. Then we are talking about flexible link. So my dear, those links which may give some deformation before transferring the motion. For example, we will be having belt drive. Okay, we will be having rope drive. So these are some wonderful examples of flexible link. Third one is fluid link. So when we are talking about fluid link, sometimes fluid also act like a link, because you must have seen this type of device for the first time in 6th class, where you were saying that there is a fluid inside and we are going to apply a force, and with the small force we are capable of lifting the car from here. So here, you know, as fluid is there, so when you will apply pressure here also pressure will come. Here area is more, so pressure into area is going to be force. So force will be more, so you can lift the car. So all the application like hydraulic brakes, very good Abhijit, all the application like hydraulic brake, hydraulic ram, hydraulic intensifier, hydraulic jack, all these applications, my dear, are related to the application of link as a fluid link. So this is something, and as I already said, turbine will not be coming in this list. Okay, turbine is having some different principle. Is it clear for everyone? Yes. So we have seen all the types of link here. So guys, just like and share the link so that others can also join. This is the application we have seen. Then my dear, we are talking about the types of relative motion, because you know that for anything to be a link, it must have some relative motion. So when we are talking about types of relative motion, there are three types of relative motion: completely constrained, successfully constrained, and incompletely constrained. Incompletely constrained can also be said as unconstrained. So my dear, what is the meaning of constrained? Like whenever more than one possibilities of motion are there, like when you were in the childhood in 11th class, 12th class, you were having many places to go. You could go for studies, you could go for playing the games if you have any interest. You could go to bad habits with some of the bad friends. So guys, you were having a lot of opportunities, lot of options, but your parents have restricted your all motions so that you can go for studies only. So whenever we have a lot of possibilities of motion, but we want some particular motion, then we need to restrict the other motion. So my dear, if we want to have the desired motion, we need to restrict the other undesired motions. So that thing is said to be constrained. So constrained, whenever we are saying, is nothing but a kind of restricted motion. Constrained motion is nothing but a restricted motion. So whenever we are having a lot of type of motion, we are going to restrict other motion and going for single motion. That thing is said to be the constrained motion. So my dear, when the constrained motion is possible by system configuration, when constrained motion is possible by system configuration, means system itself is not allowing any other kind of motion, then we call it completely constrained motion. And when you need to apply some forces to make the motion constrained, it is said to be successfully constrained motion. And when motion remain unconstrained, whatever you do, such motions are said to be unconstrained motion. There are some example, like if you have a square shaft in a square hole, then my dear, square shaft cannot rotate into square hole. Square shaft in square hole can have only this motion. So here system configuration is not allowing any other kind of motion. So we will call it completely constrained motion. Then my dear, if you have a shaft like this, and on this shaft you are having some yes, what is this? Collar. If you have collar on this shaft, then my dear, if you are going to keep it in circular hole even, then my dear, you know this motion is not possible because this collar will not allow, only rotation possible. So such is an example of completely constrained motion, where system configuration is not allowing any other motion. And my dear, then we are coming to successfully constrained motion. The example is footstep bearing. If you see this shaft can rotate and reciprocate, but you have applied external force because of which this motion will not be permitted. Now shaft can only rotate, but this is happening because of this force. So this motion is given the name of successfully constrained motion. Yes, Shivananda, hi dear, how are you? Third is incompletely constrained motion. Here you have circular shaft in circular hole without collar. So this shaft can rotate and reciprocate. So such a motion is said to be unconstrained motion. So in theory of machines, we are making the mechanisms, motion, machine only for production, so that in production we can have a desired motion of cutting tool with respect to workpiece. So my dear, that is why in theory of machines we are looking for constrained motion. Yes. So guys, moving to the next thing, that is kinematic pair. So whenever two links are connecting with each other, it is said to be a pair. Okay, any connection between two links is said to be a pair. And if the relative motion between those links is a constrained motion, it is said to be kinematic pair. So every kinematic pair is a pair, but every pair is not a kinematic pair. Is it clear guys to everyone? So as I said, any connection is said to be pair, and if relative motion is constrained, it is kinematic pair. So in theory of machines, we are looking for constrained motion. Now my dear, we are going to classify the kinematic pairs. First classification is according to the type of relative motion. According to the type of relative motion, the first type of pair is turning pair. So if we have two links connected like this, so you know here these links can have rotation with respect to each other, because about this point they can only rotate. So such pair is a turning pair. You can see this example. Between this part and this part of your hand, there is a turning pair. Okay, this is a turning pair. Is it clear to everyone? Then we are talking about sliding pair. Sliding pair means we have a cylinder, we have a piston, then between them we have a sliding pair. because piston is going to slide over the cylinder. Yes, Piyush ji, good morning. Yes, Piyush ji, good morning. Third is going to be rolling pair. My dear, if the relative motion between one link with the other is pure rolling motion. So if you see the previous case, turning pair is coming because of pure rotation. Sliding pair is coming because of pure translation. And pure translation plus pure rotation is making the pure rolling motion. So if motion is pure rolling, then my dear, we are calling it as a rolling pair. So in the pure rolling, everybody know that what is going to happen. This is a body at this point of contact. This body is rotating like this, but the velocity at this point of contact is 0, and that is why the motion is going to be pure rolling. Yes, why turning pair is not prismatic? Dear, prismatic का मतलब है if you see the motion, the piston and cylinder, they are similar. That's why it is said to be prismatic, because in cylinder you have cylindrical piston. Okay, that's why it is said to be prismatic, and throughout the motion is going to be like this. So that is why it is prismatic. Is generally have a meaning when area remains same throughout the length. So in that prospect they are calling it as prismatic pair. Okay, Shreyas. So now please tell me, anybody want me to explain what is pure rolling motion, or you know that? Let us see. Okay, if you want to see. So in pure translation motion, every point have the same translational velocity. Means every point will be having the same translation velocity like this. Okay. So if this is having 5 meters per second, every point will be moving with 5 meters per second. This is pure translation. When we are talking about pure rotation, you know, in pure rotation, the velocity profile is linear like this. Center will be having 0 velocity. So this is pure rotation, my dear. This type of motion is said to be pure rotation. Okay. So in pure rotation, if this velocity is 5, this velocity will be 0 and this velocity will be -5. So if I add both the motion, then my dear, what is going to happen? First of all, understand pure translation means what? If this body is running without rotating, if this body is moving without rotation, it is pure translation. If this body is rotating at about one point, this is pure rotation. Okay. So if you are going to add both the motions, if you are going to add both the motion, this 5 and this 5 will become 10. And this 0 plus this 5 will become 5. And this 5 and this -5 will become 0. So this is going to be the velocity profile. So in this case, you can see the velocity of this point is becoming 0 because +5 of translation, -5 of rotation. So when you are going to add both the motion, this is pure rolling motion. This is similar to the motion of the wheel of your car. Here body is in pure rolling. Okay. So in pure rolling, it is combination of translation and rotation. In such a way, the velocity of point of contact is going to be 0. That is possible only if this is 5, this is 5. Okay, means both are equal, then only it is possible. So this wonderful thing is pure rolling. And if rolling motion is there between two links, it is said to be rolling pair. So my dear, screw pair, you know, nut bolt connection. Then spherical pair, if you want to understand, it is the ball and socket joint of your body. It is bike mirror. It is your hand. You can see 3-dimension rotation is possible. 1 dimension, 2nd dimension, 3rd dimension. So between these two, there is a spherical pair. Between these two, there is a turning pair. So likewise, there are a number of pairs in our body God have given. So here, you know, the motion is going to be 3-dimensional rotation. Okay. So guys, this is the first classification over. We are moving to the second classification. Here are the examples of all. This is turning pair, pure rotation. Prismatic pair, pure translation. You can see cross section remains same throughout the length. Screw pair, nut bolt. Spherical pair, 3D rotation. Cylindrical pair, and this is planar pair. These we have not seen. We are going to see them as well. Okay. So moving further, guys. So now we are going to see the second classification. And second classification is according to the type of contact. So my dear, as per the type of contact, there are two types of pair, sorry, three types of pair: lower pair, higher pair, and wrapping pair. So lower pair are whenever the contact between two links is either surface contact, okay, and higher pair means point or line contact. What do you mean by point or line contact? Like you see in rolling pair, we were having the point contact. In rolling pair, these two bodies are connected at point contact. So this is the example of higher pair. Okay. So rolling pair is the example of higher pair. Rolling pair is a higher pair. Then if you see the cam and follower, between cam and follower also you can see there is a point contact. So it is also considered as higher pair. So cam and follower are also higher pair. But my dear, if you see the sliding pair, their complete cylinder and piston are in contact. Complete surface is in contact. So if you see all other types of pair like turning pair, like sliding pair, like screw pair, like spherical pair, all these are the example of lower pairs. Okay. Because if you see this part and this part, they are not connected at point, they are connected at surface. So you will be calling them as lower pair. And my dear, whenever one body is going to wrap over another, like belt drive, rope drive, chain drive, where one body is wrapped over other, then my dear, it is given the name of wrapping pair. Now my dear, sometime examiner in the question gives that wrapping pair ki jagah, he do not give the option as wrapping pair. He just ask that, he just give belt drive is an example of, in option you will be having lower pair, higher pair, option C will be both lower and higher pair, option D will be cannot say. So my dear, when this kind of case is coming, generally student feels it as lower pair because they feel surface contact is there. But in reality, when you will see, the pulley is also not having the very good surface finish. So the pulley in reality looks like this. There are some surface roughnesses, irregularities are there. Similarly, if you are talking about rope, if you are talking about belt, that is also having that kind of surface. So the contact is at multiple contacts, multiple points. Okay, this. So because of multiple point contact, we are considering it as higher pair. Very good, Saurabh. So we will be considering it as higher pair. So if wrapping pair is not in option, we will call it as higher pair. So guys, now we are going to see spring as a link. So sometimes you would be having this spring present. Okay. So then how you will be considering this spring to be? So my dear, in theory of machine is something important, that is how the motions are going to take place. So if you see a spring, you can take this spring between these two fingers and you can compress and expand like this. So the motion of the spring is similar to the motion of these two fingers. So we can replace this spring by these two fingers like this. So in place of this spring, you can put these two links connected with the turning pair. Okay. So this is how the spring will be replaced by two links connected with a turning pair. Is it clear guys to everyone? Yes. Now my dear, we are going to see the third type of classification, that is self-closed and force-closed pair. So self-closed means here cam is inside the follower. So as the cam will be rotating, this follower will go up or down. So this is the case of self-closed pair. And my dear, whenever we have forceful connection, here when cam is going to rotate, follower will be having upward motion. So to maintain contact between them, we are keeping a compressed spring here. So forcefully we are maintaining the contact. In the previous case, even if follower wants, he cannot go away from cam because cam is inside the follower. But in this case, follower can go upward, but spring is there to make the contact between them. So this is forceful contact. So it is said to be forced closed pair. Okay. Yes. One more thing I would like to tell you, that one higher pair is equivalent to two lower pair. Okay. Because one higher pair is doing the same work which two lower pairs together are doing. Yes, Patti, yes, dear. So when we are going to see this higher pair and lower pair connection, you are having this cam and follower. Here this is link number 1, cam is link number 2, follower is link number 3, and this is link number 1. So you can see total number of links are 3. And if you see, this is a turning pair because rotation is going on. This is a sliding pair because sliding is going on. And this is a higher pair. So there is one turning pair, one sliding pair, and one higher pair. Is it clear? So my dear, if that is the case, on the other hand, if I will be talking about, we are having, let us say, a slider like this, and this slider is having the sliding motion inside the cylinder. This is connecting rod, this is crank, and this is fix. So here if you will see, this is link number 1, link number 2, link number 3, link number 4, link number 1. So links are 4 here. This is turning pair, this is turning pair, this is turning pair, and this is sliding pair. So we have 3 turning pair and 1 sliding pair. So if you see in both the mechanism, rotation is converted into the translation. Rotation of crank is giving you translation of slider. Rotation of cam is giving you translation of follower. So my dear, any two mechanism, if they produce same type of motion, they may be different in your eyes, on your view, but my dear, as per the theory of machine aspect is, it is very clear. If two mechanisms are giving the same relative motion, they have the same meaning for term. So according to theory of machines, both are doing the same work. So if that is the case, both are equivalent mechanism. So in that case, you see here, we are having 2 lower pairs and 1 higher pair. But here we have 4 lower pairs. Okay. So it means that 2 lower pairs are equivalent to 1 higher pair. So here the purpose solved by 1 higher pair. Here the same is done by 2 lower pairs. Okay. So always remember this, 1 higher pair is equivalent to 2 lower pairs. Moving further, guys. Now we are talking about the different types of joint. When 2 links are joined together like this, you can see 1 and 2 links are connected at one joint. It is said to be binary joint. When, my dear, we have 3 links connected at one joint, it is said to be ternary joint. And one ternary joint is equivalent to 2 binary joint. Okay. Why? Because if you make a binary joint between 1 and 2, 1 binary, second binary between 2 and 3, third binary you will get automatically. So that is why one ternary is equivalent to 2 binary. Quaternary means where 4 links are connecting together, and my dear, one quaternary link is equivalent to 3 binary link. You might be thinking why we are converting these to binary, because all our formula in theory of machines are having the binary joint. Okay. So binary joint in the formulas. So that is why we are converting all the joints into binary. So one ternary is 2 binary and one quaternary is 3 binary. Are you getting it, guys? Everyone, please tell me that. Then we are moving to kinematic chain. Slowly we are moving towards the word mechanism. So we have discussed already what is link. We have discussed already what is pair. Now we are talking about the chain. So when a number of links are connecting together in such a way that first and last link are connecting together, it is said to be a chain. And if the relative motion between all those links are going to be yes, constrained, then we are going to call it as kinematic chain. So my dear, whenever we have a kinematic chain, if we are going to fix one link of that chain, it will become a mechanism. And whenever we are going to use a mechanism or a group of mechanism to get some work output, it becomes machine. Okay. Like IC engine is a machine, single slider crank mechanism, that chain, whenever one link is fixed, is said to be a mechanism. So when it is used, it becomes machine. So my dear, if you want a machine, for that we require some mechanism. And when you will get mechanism? When we have a kinematic chain. So my dear, overall we are looking for a kinematic chain, because as I said, guys, this is a revision session. So whatever you studied in 80 hours, I am going to complete in 2 to 2.5 hours. So don't compare, okay, because this is for revision. Those who have already studied theory of machine, they will get a good revision. So here those stories which I was telling you in the class, that is not feasible. Okay, so when we are talking about this, we are looking for a kinematic chain. So my dear, when we are looking for a kinematic chain, because chain will become mechanism, mechanism will become a machine. Okay, so for that there are some condition. L is equals to 2p minus 4 है ना, and J is equals to 3 by 2 L minus 1. Yes, what was the formula? What was the formula? Anybody remember? Yes, let us check. 3 by 2 L minus 1. What after that? Anybody? किसी को याद है? बोलो भाई. J is the number of joints. Yes. Okay. So dear, that is actually there are two formulas what I have given to you. One formula is L is equals to 2p minus 4. Here in this formula, L is the number of links, P are the number of kinematic pairs. So you are telling the formula of degree of freedom, okay? So you are telling the formula of degree of freedom. So when we are talking about this, here there are number of links, here there are number of pairs, okay? So when we have joint is equals to 3 by 2 L minus 1. So my dear, when we are talking about this L minus 1, here L is the number of links, J is the number of joint, but don't worry, as you remember, we are going to use the formula of degree of freedom. So we need not to write this. I will be directly telling you the degree of freedom. Otherwise you will get confused, and degree of freedom formula comes from that only. Okay. Yes. So you have studied this formula. F is equals to 3L minus 1 minus 2J minus H. So my dear, this is what you have studied, but this is for degrees of freedom. This formula actually is coming from the same what I was writing properly. So this is what you need to remember. So I am not writing other formulas, because this one formula will solve over all the purposes. Why? Because finding out kinematic pair is going to be the difficult thing. So better we will be going for the degree of freedom formula. So we are reaching to the concept of degree of freedom. This is the first heading from where numericals are coming. Okay. First heading from where numericals are coming. So when we are talking about degrees of freedom, my dear, you must be aware degree of freedom are the number of independent motions in a mechanism. Okay, number of independent motions in a mechanism. So my dear, if we have any link in 3 dimension, we can have 6 type of motion. One is translation in X, translation in Y, translation in Z. One is rotation about X, rotation about Y, and rotation about Z. Okay, so 6 motions are possible. So maximum degree of freedom of a link in 3 dimension is 6. If any of the motion is restricted, we will call it as F is equals to 6 minus R. But why these restriction will come? Due to pair. So whenever you have pairing with someone, restrictions are coming. You are living alone, you are having 6 degree of freedom, means you are enjoying the maximum degrees of freedom. When you are having some relationships, then you have to be restricted based on that relationship, otherwise the relationship can break. So for that some restrictions are coming, and then the formula will become 6 minus R. So this is the formula for degree of freedom when a link is with some pairing arrangement. Okay, you might be having one confusion, why not degree of freedom are 12? Why not degree of freedom are 12? So for that you must be aware that 12 degree of freedom will be considered where? In the production part. Why? Because there, if we have a workpiece like this and tool like this, then if cutting tool is moving in this direction, cutting will happen. In this direction, cutting will not happen. So there positive X and negative X will be having different meaning. But in theory of machine, our target is to create the motion. So as we are only talking about creating the motion, for us X direction, positive, negative, we will consider same. Okay. So my dear, as this is the formula revision session, I would be directly writing the formula for degree of freedom for a mechanism. So when we are having a mechanism, for that the equation is given as 3L minus 1 minus 2J minus H. This is the formula for degree of freedom for a mechanism in 2 dimension. Because in our syllabus 3 dimension is not there. Like in 3 dimension maximum motion are 6. In 2 dimension maximum motions are 3. So for a link maximum are 3, and for a link in pair it is 3 minus R. So when we are talking about a turning pair link can have only one rotation motion. All other motions are not possible. Okay, so that is why for a turning pair degree of freedom will become 1. Now you would be remembering when I was teaching that in class, I have taken 30 minutes for that turning pair. Okay, but here it is a revision session, so I would be just giving you a revision. So this session is helpful for those who have already studied the theory of machines. They just want a quick revision for remembering the things, nothing else. Okay, so the same subject which I taught for 80 hours, I am going to deal with in 2.5 hours. Only formulas are there. Okay, but this is a very good session for revision purpose. So this equation what I have written before is said to be Kurzbach equation. Everybody would be aware L is the number of links, J is the number of binary joint, H is the higher pair. So L is the number of links, J is the number of binary joint, and H is the number of higher pair. There I also told you how this equation came into picture, if you remember that. Okay, so I also derived this relation, how it comes. Here no derivation, we are directly writing the formulas. I feel you understand because this is a formula revision session. Moving further. So guys, there are some cases where some redundant motions are there. What are redundant motion? Like if you see here, this link is placed with the sliding pair in this groove. This is the groove. So this time it is not connecting with turning pair, but it is connecting with sliding pair. So this is a place where the link is kept like this. So if you will be slightly giving a push to this link will go away. And if this link will go away, the motion of this link will not be affecting input and output link. So if any motion is present in a mechanism which is possible without having the motion of input and output link, such motions are said to be redundant motions. And if you want to find out degree of freedom of this, we need to subtract this redundant motions part. So the equation was modified and given the name of modify Kurzbach equation. This is 3 into L minus 1 minus 2J minus H minus FR. Here FR is the redundant degrees of freedom. So this link, you will not say the link has no use. That is different thing. That is the concept of redundant link. It is not redundant link, it is redundant motion. Here this link is having an extra motion which can be reduced because that is not playing any part of degree of freedom. So that is the point. In actual, what will happen, if you will give rotation to this link will go away and this will become a 3-link thing. And you know, whenever we have this is becoming truss. Truss is not having any relative motion. So degree of freedom for this truss is going to be 0, you know that. So that is why we are using this. So if you are going to use it, number of links are 4. Number of joints, you know, this is binary, sliding pair is also considered as binary joint. This is also binary, this is also binary. So this is 2 into 4. There is one redundant motion. So the answer will be coming out to be 0 because it is converting into truss like that. Okay, so that is why answer will be coming out to be 0. So guys, this is Kurzbach paradox. Kurzbach paradox. This is something on which neither Kurzbach equation is valid nor modified Kurzbach is valid. Because if you see this, we have this as link 1, this as 2, this as 3, this as 4 and this as 5. So if you see, the number of links are 5. The number of joints 1, 2, 3, 4, 5, 6. So number of joints are 6. And there is no higher pair, no redundant motion. Why? because here if you will try to rotate this link, entire mechanism will rotate because it is double parallelogram linkage. It is double parallelogram linkage. So my dear, when you will apply the formula 3 into L minus 1 minus 2J minus H minus FR, FR is 0, H is 0. You will put 3 into 5 minus 1 minus 2 into 6. So you will be having 12 minus 12, answer will be coming 0. But you know this linkage is used in railways to couple the wheels. And where you are coupling the wheels in the railways, there you have seen that this motion is going on, that's why wheels are rotating. So their degree of freedom is coming out to be 1 actually. So degree of freedom is coming out to be 1, but here we are getting 0. So as Kurzbach equation is giving wrong answer, we call it as Kurzbach paradox. The reason behind that is, if you see the motion of this link number 2, 4 and 5, if you have this link number 4, or if you don't have this link number 4, the relative motion between input and output link will not change. So these are the situation where we can say this link number 4 is a redundant link. Means we can remove this link for the calculation purpose because it have the same motion as input and output have. So that is why for calculation purpose we remove such links, and if you will remove this, it will become 4 bar mechanism. The number of link will be 4, the number of joint will be 4, so answer will be coming out to be 1. So that is how the redundant link and redundant motions are two different things. Okay, moving further, Grubler's equation. You know that my dear, Grubler's have said that we are talking about the mechanism for which higher pair is 0 and degree of freedom is going to be 1. So he was interested in the mechanisms which are made up of without any higher pair. I feel you would be remembering when degree of freedom is 0, we are getting frame. When degree of freedom is 1, we are getting we are getting mechanism. Degree of freedom more than 1, we are getting unconstrained. Okay, so my dear, when we have degree of freedom 1, higher pair 0, let us see the formula of Kurzbach. You know higher pair 0, degree of freedom 1. This is the equation. 3L minus 2J minus 4 is equals to 0. If you see this equation, 3L minus 2J minus 4, 3L minus 2J plus 4. If you see this, my dear, you are getting the subtraction of this from this and you are getting 0. So my dear, you know that when J plus 2 also, if J plus 2 you have. So my dear, if you are subtracting this from 3L, it is coming out to be 0. You know that if we are talking about J plus 2, it can be odd or even. But when it will be multiplied with 2, it will become even. So this quantity is even. So if you are subtracting even from odd, you will never get 0. You will get 0 only if you are subtracting even from even. So it means 3L will be even. 3 is odd. 3L can be even if L is even. So it means Grubler have said the number of links should be even. And the first even number will be more than 2. So we will be using L is equals to 4 for the minimum number of links. So guys, the point is Grubler said that if you want to make a mechanism without any higher pair, then the number of links should be even and that even number should be starting from 4. So when he said that, the researchers' work becomes 50%. Previously they would be trying for link 5, link 6. Now they will not try for 5 because they know odd number of link will not give them a mechanism. So that is why, my dear, with this Grubler have given a wonderful thing, and because of that he was given a lot of prizes because of this wonderful work. Okay, so if you see, okay, this is a question I am taking, otherwise this is formula series, but still I am taking one question for your convenience. Okay, This is link number 1. This is hashed part, link number 2, link number 3, link number 4, link number 5, link number 6, and link number 1. So you can say, my dear, number of links are 6. If you see the joint binary, 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 and binary. So 1, 2, 3, 4, 5, 6, 7. Number of joints are 7. Degree of freedom are 3 into L minus 1 minus 2J minus H. So you can see higher pair are coming out to be 0. So you can put 3 into 6 minus 1 minus 2 into 7. So guys, it is going to be 15 minus 14. Answer will be 1. So this is how the first type of questions are coming on degrees of freedom. Very good space aspirant. Sachin, Midun, Pattipati, Kartikeya. बहुत बढ़िया. Moving further, guys. So these are some other examples you can try, but as this is formula session, I am not going into questions. Now we are moving to the 4-bar mechanism. Okay. So the first mechanism we are getting with 4 links. Here if you see the 4 link, this is said to be the best position of a mechanism because all input and output are given with respect to this position. Then my dear, this is input and output. So if you see, the motion of input and output are going to be pure rotation because they are connected with the fixed link. So because of that, their motion is well-defined motion. That is why this is said to be the second best position. As the motion is well-defined, it is said to be the second best position. But my dear, when we are talking about the link number 3, which is just in front of fixed link, this is said to be the coupler. This is not connecting with the fixed link. This is connected with the 2 moving links. So my dear, that is why its motion is not a well-defined motion. Its motion is a general motion. Means I am not saying it is having variable velocity, but I am saying it is having variable motion. Means sometime it is having translation plus rotation components. Sometime translation will be more, sometime rotation will be more. So the motion of this link number 3 is given the name of general motion. Okay guys, so it is given the name of general motion. General motion is a combination of translation and rotation, and that is also rough combination. So translation and rotation components are also variable. Sometime translation will be more, sometime rotation will be more. So such kind of things are going on. So my dear, such motion is given the name of general motion. In this mechanism, there are 4 turning pair, 1, 2, 3 and 4. So guys, if you see this, whatever I have shown you, you can compare these position. How? Like this is link number 1 is the best position. This position is governing the motion of all. It is like the position of Prime Minister in our country or our father in our home who is going to govern everything. Then this is second best position is the position of minister, bureaucrats, which can do anything for their self at least. This is the position of the common man who is going to be dancing based on the rules which are coming from these and these sides. Okay. So these are the analysis of 4-bar mechanisms. Now we are going for inversions, which is a very, very important heading. And from here, a lot of questions are coming. Okay. So when we are talking about the inversions, my dear, so if we have a 4-link kinematic chain, we have a 4-link kinematic chain, 1, 2, 3 and 4. This is a kinematic chain. You know that if I want to make a mechanism from a kinematic chain, what I need to do? Yes, very good, Kalyan. So if I want to make mechanism from this kinematic chain, what I need to do? I need to fix one link of this kinematic chain and I will get a mechanism. But which link I will be fixing? For that I have 4 choices. Choice number 1 link, choice number 2 link, choice number 3 link, choice number 4 links. So my dear, one by one, first if I will be fixing 1, then I will be fixing 2, then I will be fixing 3, then I will be fixing 4, only one at a time. I will get a set of mechanism. So that set of mechanisms is given the name of inversions. Okay, that set of mechanism is given the name of inversions. So my dear, if someone asks you what are the maximum number of inversions possible for a given kinematic chain, it will be equals to the number of links. I said maximum number of inversion will be equals to number of links, but sometime we may not get that much number of inversions. I am giving you an example. First of all, I would like to say that if any link is found to be in complete rotation, that link is given the name of crank. And if you are going to see the partial rotation, then that link is given the name of rocker. So my dear, first of all, we are going to fix link number 1. Okay. So whenever we have fixed link number 1, we have seen input is having complete rotation. Complete rotation means crank. Output is also having complete rotation. It means crank. So the name of the mechanism is crank mechanism or double crank mechanism. This is the case when two links are going to have complete rotation like this. Okay, this is the case. Second is, if we are going to keep link number 2 as fixed, we have seen that input link was found to be crank and output link was found to be rocker. So input was having the complete rotation and output was having the partial rotation like this. Okay. Then my dear, we have seen the third possibility where link number 3 was kept fixed. Then we have found this was becoming the rocker and this was becoming the crank. Okay. So this time this was rocker and this was crank. Okay. Like this, opposite to the previous one. When we have fixed the fourth link, we are getting rocker here and rocker here. These are the 4 possibility I am talking about. So rocker means this type of motion. Okay, this type of motion is rocker mechanism. So guys, if you see these 4 possibilities, you can say these are 4 inversions. But my dear, the reality here is, if you see crank rocker and rocker crank, then if I am saying this is crank rocker, if I will be rotating by 180 degree, it will become rocker crank. So if you have a machine in your home and you rotate it by 180 degree, the name of machine is not going to change. So the point is, crank rocker and rocker crank is only one type of relative motion. And until we have one type of relative motion, those mechanisms cannot be different. So crank rocker and rocker crank are not two different mechanisms but the same one. So we will call crank rocker and rocker crank. They are the same mechanism. They are not different mechanism. Is it clear? So guys, if someone asks you for simple 4-bar mechanism, you will call there are 3 inversions. There are 3 inversions. One is double crank mechanism. Other is crank rocker or rocker crank. Third one is double rocker mechanism. Then we are moving to the Grashof law. So my dear, we have seen the types of inversion we can get. Now out of those types of inversions, when we are going to get what? It was given by Sir Grashof. And Sir Grashof have given a wonderful law on that. Sir Grashof said that if you are looking for at least one crank, why at least one crank? He was looking for a continuous motion. You know, crank is rotating continuously, whereas rocker is having a discontinuous motion. So if you are looking for a continuous motion which is there with the crank, so continuous motion is coming with crank. So he was looking for at least one crank in a mechanism. So at least one crank means either double crank mechanism which will give you continuous motion, or crank rocker mechanism will give you continuous motion. Double rocker is having this discontinuity like this. Okay, so he wanted continuity. So Grashof said that if you want at least one crank, then the summation of shortest and longest link should be less than equals to P plus Q. Okay, means there are 4 links. One is shortest, other is longest, other is P, other is Q. So let us say one link is having a length of 2 mm, other is having a length of 8 mm. This is having a length of 4 mm, this is having a length of 5 mm. So you can see here 2 plus 8 is becoming more than 5 plus 4. So this is the case when Grashof law is not valid. And when it is not valid, you are going to get discontinuity, which is nothing but double rocker mechanism. So if you want crank rocker mechanism, okay, just wait guys, you need to wait for 1 minute, okay, just wait for 1 minute. I need to apply the charger. Yes guys, so we have seen this is the condition, S plus L is less than equals to P plus Q. If that is satisfied, then only we can think of the one crank at least. So my dear, when we are going to have S plus L more than P plus Q, or S plus L equals to P plus Q, if we have these two cases, then what Sir Grashof have said, if you are going to keep the shortest link to be fixed, you will be getting double crank. This is based on the observation of Sir Grashof. Okay. So based on the observation of Grashof law, this was given that if shortest link is fixed, the mechanism will be given the name of double crank mechanism. And if shortest link is becoming either input link or output link, then you will be having crank rocker mechanism. Okay. And when shortest link will become the coupler, then you will be having double rocker mechanism. Now my dear, this was the condition when even the Grashof law is satisfied, still we are not getting any crank. So this was a challenge to the Grashof law, but my dear, as Sir Grashof have done this work in 5 to 6 years with a lot of observation, so maybe it is not valid for this case, but still we are calling it a law, and we are calling that this is coming because of misutilization. Because where you want to keep a shortest link, that is totally your choice. If you are keeping it as coupler, you will not get any crank. It means you intentionally want double rocker mechanism. Okay, so that is the feeling of, you can say, crank rocker double crank mechanism. We have already talked about this case. So now we are talking about the third case, where we have two shortest links and two longest link. So this time two links have same length, other two links also have same length. If you are going to connect, this time also S plus L will become equals to S plus L, law satisfied. So if you will be having the mechanism, this time two mechanisms are possible. First mechanism is when you connect shortest with the longest and longest with the shortest. Then you will be having this, which is said to be parallelogram linkage. Okay. And when you are going to connect shortest with shortest, longest with longest, then my dear, this linkage is said to be deltoid linkage. So my dear, in these two mechanisms, there is something special, that in these two mechanisms, you will always get one crank. If shortest is fixed, you will be having double crank. If longest is fixed, you will be having crank rocker. And my dear, the point is, if you are talking about parallelogram linkage, in this case, you will always get double crank. Okay, always get double crank. That's why these chains are also said to be the golden chains. In the classes, I have derived it for you. That's why how 80 hours are converted into 2 to 2.5 hours. Here I am just telling you, there I was deriving all the things. Okay, I was showing all the things with the animations. So guys, that's why I said to be golden chains, as they always follow the Grashof law. Everybody understood now? Are you getting it now? Because this is formula series. In 2 hours I need to cover all the formulas, so I cannot go for the detailed animations and derivation. When law is not satisfied, you will say double rocker mechanism. So we have converted this. Now we are coming to, my dear, something very important, that is the application of 4-bar mechanism. The very first application is beam engine mechanism. So my dear, in this case, if you see, this was the very first attempt by Sir James Watt for making the steam engine, as the entire work was going on to make the first efficient engine for locomotive. So this was the first attempt of Sir James Watt. Okay. So here if you see, this is fixed link, link number 2, link number 3, link number 4. So if you see here, here is rotation, here is oscillation. So if you are going to have a cylinder with this, then that cylinder piston, if you are going to put, so my dear, you know one thing, that as it is oscillating, so whenever this will be going up, this will be applying some unbalanced forces here. So because of these unbalanced forces, this mechanism was not able to run at very high speed, and it failed after 60 to 80 RPM. So it was unable to give you that speed which was required for locomotive. So this was a failed attempt by Sir James Watt, but this was used. This is used nowadays also by ONGC, and they are using it for what? You know that, for fuel refining, okay, for oil refining processes. And even the same mechanism is used by the tailors in the sewing machine. If you have seen the sewing machine, they are giving oscillation by their foot, and they are getting rotation of the machine. So guys, this is how failed mechanism are also used. So swing machine and oil refineries are the application of this mechanism. Okay, you can see this is the case. Second is coupling rod of locomotive. So my dear, if you see, you are going to join 2 wheels of rail, 2 wheels of train if you want to join, then my dear, you will be having this as coupling rod which is joining the 2 wheels. So you know this is a parallelogram mechanism. So this is said to be coupling rod of locomotive. Even if you are going to join 3 wheels, you need to go for the double crank mechanism. Is it clear? Yes guys. So we have seen these application of simple 4-bar mechanism. This is the animation of coupling rod of locomotive, how the wheels are coupled with each other. Okay. Now I am telling you about the transmission angle, my dear. So you know that in this simple 4-bar mechanism, if it is a crank rocker mechanism, then this link is given the name of crank, and this is given the name of rocker. So if you have this as crank, this as rocker, then my dear, this angle is given the name of crank angle. And this angle is said to be the transmission angle. Okay guys. So when we have done the derivation in the class, we get to know that this transmission angle is going to be minimum when this theta is becoming 0. And this transmission angle is going to become maximum when theta is going to be 180 degrees. And you know, transmission angle should be near to 90 degree. If it is going much beyond 90 degree, maybe lesser than 45 degree or more than 115, 135 degree, the mechanism will become a low quality mechanism, and it may not have the complete output motions. So you have studied this about the transmission angle. Now we are talking about the mechanical advantage. So you know that mechanical advantage is defined as output force but a input force. You also say that output torque or input torque. And my dear, in thermodynamics we have defined efficiency. Efficiency is defined as power output by power input. So power output is given as torque output into omega output, or torque input into omega input. So if you see this efficiency, it can be written as mechanical advantage into omega output by omega input. Why? Because this is mechanical advantage. So you can see that mechanical advantage can be written as efficiency times omega input by omega output. This is the relation between them. Efficiency is always less than or equals to 100%. Mechanical advantage is always more than 100%. Otherwise, it will not be an advantage. Okay. So guys, as I said, I am telling you all the formulas directly. Now I am talking about the toggle positions in a mechanism. So my dear, toggle position is a position when one link is going to change its direction of motion. Like if it is a crank rocker mechanism, this will be rotating like this and rocker will be having this motion. So when rocker will be reaching to this or this position, then my dear, here it is going to change the direction of motion, here also going to change the direction of motion. So for these two positions, the velocity of link number 4 is becoming 0. So these positions are said to be toggle mechanism. Why it is so? Because if you see the mechanical advantage formula, it was efficiency times omega input by omega output. You know, fourth link is output. So at this position, efficiency into omega input by 0 will give you infinity. So toggle positions are those where you are going to get a mechanical advantage of infinite. Okay. So this is the definition of toggle position. Now we are moving to single slider crank mechanism. As I said, this is the formula session. I will just tell you the name of inversions, not going into detail of that. Otherwise, we will be unable to complete even 2 chapters. Okay. So don't worry. I am feeling that we need to go for one more session on TOM plus MD. One session is not enough to complete it, but don't worry. We will try to cover at least 3-4 topics today, and one more session we will keep on next Saturday or Sunday. Okay, to complete it. So we are going to see single slider crank mechanism. You know that, my dear, here this is a cylinder, this is piston, this is connecting rod, and this is crank. Here this is turning pair, this is turning pair, this is turning pair, and this is sliding pair. So you can see 3 turning pair and 1 sliding pair. In simple 4-bar mechanism, we were having 4 turning pairs. So when one turning pair of simple 4-bar mechanism is converted into sliding pair, it becomes single slider crank mechanism. So this you can say is one configuration of 4-bar mechanism only. And 4-bar mechanism was the first mechanism of the universe. That's why we call it as simple 4-bar mechanism, what we have studied before. This is the other configuration of this. So this is not said to be simple. Okay, simple is the first one. This is the second one. So if you see this, here, my dear, there are 4 links. One is cylinder, other is piston, other is crank, other is connecting rod. So if you see these 4 links, there are once again 4 possibilities of inversion. When you will be fixing one link, you will get one inversion. So guys, for 4 links, we can get 4 inversions. I am telling you what are the inversions we are going to get. When cylinder will be kept fixed, you will get either reciprocating IC engine or reciprocating compressor. Then if you will be fixing the piston, you will be getting the hand pump. You will be getting the hand pump. If you will be fixing the crank, we will be getting Whitworth quick return motion mechanism. And when you will be keeping the crank to be fixed, you will be getting one more thing, that is rotary IC engine. So these are the things which will be getting. So both are 2 configurations of same mechanism. Okay. So when you are keeping the cylinder fixed, you are going to get rotation to reciprocation. This is the relative motion. Here, when you are fixing the piston, you are going to get oscillation to reciprocation. Here you are going to get rotation to rotation. And when connecting rod is fixed, you will be getting 2 types of mechanisms once again. Sorry, 2 configuration, mechanism is one only. That is crank and slotted lever mechanism, quick return, and second is oscillating cylinder engine. Oscillating cylinder engine. So my dear, if you see these, keeping 1 1 1 fixed, you are getting these kind of inversions. So here you are going to have the motion to be rotation to oscillation. If you see, all 4 inversions have different relative motion. Here you are getting rotation to reciprocation. Here we are getting oscillation to reciprocation. Here rotation to rotation. Here rotation to oscillation. So all 4 relative motion are different here. So guys, let us see. The first inversion is IC engine or compressor. So if you are having input at crank, output at piston, it is compressor. If you have input at slider, output at crank, it is IC engine. So this you are getting when cylinder is kept fixed. When crank is fixed, we are getting Whitworth and rotary. So one by one, let us see that. I already told you this is, first of all, when connecting rod is kept fixed, we are going to have this crank and slotted lever mechanism. Here you are going to apply some motor which will give rotation to the crank. When the crank will be rotating, crank is connected with the slider. So this slider will also rotate. This slider is kept into this slotted bar. So slotted bar will oscillate like this whenever slider is going to rotate like this. So when slider will be going from B1 to B2, this is going from C1 to C2. And when the slider is going from B2 to B1, then it will be coming back from C2 to C1. So you can see in forward motion, you are going to cover beta angle. In backward motion, you are going to cover alpha angle. And you can see beta is more than alpha. As motor is going on with constant angular velocity. So beta by time, angle by time of forward stroke, angle by time of return stroke. Omega is a constant. But you know beta is more than alpha. So obviously time of forward stroke is more than time of return stroke. So we are going to have forward stroke to be slower and return stroke to be faster, and that is the requirement also. Because in case of shaper and planer, we will be going in forward stroke slowly, 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 slowly. In return, we will be coming faster. Forward slowly, 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 return will be faster. Why? Because the return stroke is idle stroke. So this type of mechanism is used in shaper and planer. So my dear, if I am saying that this crank is having a radius of R, this fixed link is having a length of L, this slotted bar is having a length of S, then the stroke length covered by C1, C2 or ram R1, R2 is given by the formula, as 2 times length of slotted bar R upon L. This is the formula for stroke length, which depends on 3 parameters. So changing any of these parameters, we can change the stroke length of the mechanism. So it is used in shaper and planer. So that we have already discussed, that beta by alpha or TF by TR. This is given the name of quick return ratio. Okay. So TF by TR, beta by alpha is quick return ratio. Okay guys, so this is Whitworth. In Whitworth, when we are going to say, initially this was used for shaper and planer, but nowadays it is not used, because here stroke length is given as dia of smaller circle. Dia of smaller circle. Okay, so here only one parameter is there to change the stroke length. There we have 3 parameters. Okay. In this mechanism, I feel you can understand, when this is the fixed link, motor is attached here. So when from this to this rotating link will be going on, then my dear, you know that this point on this smaller circle will be moving from C1 to C2, ram will be going from R1 to R2. So reverse will happen for second angle. So once again, here also the same story is going to repeat. I feel everyone understand that. Okay, so this is the, okay, next is oscillating cylinder engine. I am showing you the animations also. This is the oscillating cylinder engine. You know that in this oscillating cylinder engine, this is used in the small ship engine because of its compact contraction. Okay, if you see this, here this cylinder is rotating like this. This is the second attempt by Sir James Watt and team to make the steam engine. It was also failed attempt. Why? Because very heavy cylinder was having rotation about a small pin. So if you would be having more than 60 RPM of this cylinder, then this mechanism would be failed. So my dear, that is why this is also giving you very less speed of 60 to 80 RPM. So this is used for demonstration of small ship engine nowadays also. Okay, it is also said to be, it was given by, as I already said, it was the second attempt. Okay, so you can see this is the animation of the same. Moving further to rotary IC engine. In rotary IC engine, my dear, what is going to happen, I am telling you. In this, let us say this is the case of rotary IC engine. You can see there are a number of cylinders. All these cylinders are joined on a cylinder block. So my dear, whenever combustion will be happening here, there will be a pressure on the piston. When piston will be trying to move, as you know that here this link is fixed, so it cannot rotate this link, so it will be rotating this cylinder. Similarly, other also will rotate it because the complete block is having these cylinders. So the entire cylinder block will be rotating, and this rotating cylinder block is connected with the aircraft. So the very first aircraft made by Wright brothers was using this concept only. Okay, then we are having the animation. This is how it is going on. So it is showing in different cylinder combustion is going on. Then this hand pump, you know that in hand pump, when this slider will be coming up, water will be coming down, and this is happening when this link is oscillating. So input is oscillation, output is reciprocation. If you remember in class, in 30-35 minutes, I have shown how hand pump mechanism is being made. Okay, so here we are having revision, so not going into that detail. So this is the double slider crank mechanism now. If you see here, two turning pairs are converted into two sliding pairs. Okay, two turning pairs are converted into two sliding pairs, so it is becoming double slider mechanism. If you see this mechanism, this is said to be slotted plate. This is slotted plate. You can see this is one slider, this is another slider, and this is the link connecting the sliders. Okay, so my dear, here also we have four links, four possibilities are there. So the first inversion you will be getting by fixing the slotted bar. The name is elliptical trammel. If you will fix any of the slider, you will get Scotch yoke mechanism, which is used to produce SHM. And if you will be fixing the link connecting the slider, you will get an Oldham coupling, which is used to join laterally misaligned shaft. Okay, so guys, these are the three types of inversions we are getting. This is elliptical trammel. So elliptical trammel is used to plot the ellipse. If you would be putting your pencil at any of the point of this AB, that will be plotting the ellipse. When this slider will be coming down, this will be going away. When this will be coming up, then my dear, this slider will be coming in this direction. So this slider will move in this way, this slider will move in this way. This is how the motion is going on. I will show you the animation of this. This is the elliptical trammel. So you can see any point on this link will be plotting an ellipse. So that is why the name of mechanism is elliptical trammel. Are you getting it or not? We can even prove it. That if we are going to have these two points A and B, one A, other B, so you are going to see the locus of any point here, P, X, Y. So you know that this angle is theta, this angle is theta. So you can write, if I give the name here Q, here R, then you can write here from this triangle and from this triangle sine and cos theta. So you know what is if you see this is a triangle, this is a triangle. Okay, so you can have this triangle, and using this triangle you can derive the equation of the ellipse. Okay, if you see this triangle, if you see cos theta is going to be this divided by this. Okay, and if you see the sine theta will be this divided by this. So you need to write cos theta and sine theta and when you will be using the equation sin square theta plus cos square theta is equals to 1, you will get the equation of ellipse. So this is how we are going to put it. You know that this distance, if I am putting this point as xy, then this is going to be y, this is going to be x. So here you will be writing sin theta. Sin theta is nothing but y by bp. From here you will write cos theta. It will be x by ap. So you will be doing sin square theta plus cos square theta to be 1. And you will get the equation of ellipse. So x square by ap ka square plus y square by bp ka square is equals to 1. This is the equation of ellipse. That is why it is given the name of elliptical tremel. Moving further, guys, this is Koch-Yoke mechanism. If we are fixing this slider will not be moving. And if this slider will not be moving, my dear, then if you will give rotation to this link, after some time it will reach here. So slotted plate will move here. So slotted plate will be having this type of motion, which is SHM. So on rotation of this, you will get SHM. So this mechanism is also shown by this. This is one of the representation of Koch-Yoke mechanism. It is used in power hexos. It is used in power hexos, Koch-Yoke mechanism. Guys, you can see the animation. So just like and share the session who have not done till now. Moving to the next thing, that is Oldham coupling. Here you know that coupling means which is joining two shafts. Yes, Kalyan. So I also feel the same. But don't worry, actually first chapter takes more time. In other chapter, when we see the formulas only, it will hardly take 1 to 1.5 hours more. Like if you see governor, if I go for the formula, there are 8 formulas only. There I will not be teaching, okay, I will be giving you formulas only. Because crash course is about to come in the next month. There we will see all the things in detail, okay. So when we are talking about Oldham's coupling, when we are joining the two shafts, it is said to be a coupling, okay. So my dear, if you are going to join to collinear shaft, it is said to be flange coupling. If you are machine design also, dear, machine design and vibration, we will keep it in one session. So I will be taking on next Saturday and Sunday to revise both, okay. So don't worry about that. Then my dear, we are having, let us say, this is one slider, this is another slider. If we are having one shaft here and you are rotating that shaft, then this slider will try to rotate like this. When slider will rotate, slotted bar will also rotate like this. And when slotted bar will rotate, this slider will also rotate like this. And then this shaft will also rotate. So when we are joining one shaft here, other shaft here, they are two laterally misaligned shaft. Okay, so they have some lateral differences. So that is why this is said to be the Oldham's coupling. And guys, this is used to join two laterally misaligned shaft. This is, you can see the axis of one shaft, the axis of another shaft. And this is the lateral misalignment of D. As you know, two things are moving at different axes. There will be some sliding. So velocity of sliding is given as d into omega, where d is the offset of the shaft. This is how the things are going to be given. So here first chapter is over, okay. Moving to the second chapter. Don't worry, we will keep the session only up to 1 or 1:15, not more than that, okay. Because other chapters are going to take less time. Actually, what is in this first chapter, there is not much formula. So without concept, showing formula will be useless, okay. But in other topics like flywheel, there are some formulas, you know. So there we will see only formulas, okay. Now my dear, we are talking about velocity and acceleration analysis. And the very first approach is instantaneous center approach. So I would like to say that instantaneous center, what it is actually. So my dear, when we are talking about the simple 4-bar mechanism, you know that we have these 4 links. This link 1 is fixed. This link 2 is having pure rotation about this point. Link 3 is having pure rotation about this point. But this link number 4 is having the general motion, okay. And when we are talking about general motion, it is the combination of pure translation and pure rotation. So in reality, it is the combination, and this combination is also rough combination. So sometime translation 70%, rotation 30%, sometime translation 60%, rotation 40%. So this type of motion is something which can just shake our souls. Okay, yes, very good, Kalyan. Okay, so when we are talking about this eye center approach, in this eye center approach, what is eye center actually? So you know, whenever some motion is pure rotation, like if this is the rotation motion, this is the center, okay, this is the fixed center. But there are some motion which are not actually rotation, but we want to see them as rotation motion. So whenever the motion is not rotation actually, but about some point it feels like rotation, then that point is given the name of instantaneous center. So the point is clear. We are going to convert this general motion into rotation, and the point about which it will be rotation, it is said to be eye center. That's why the name of approach is eye center approach. Okay, so my dear, when eye center is not a fixed point, it is a moving point. So when something moves, it follows some path. Path is given the name of locus. So my dear, locus of eye center is given the name of centroid, and the locus of eye axis is given the name of exode. Like if this is the eye center, then my dear, any axis passes from this point is said to be eye axis. Okay, I am giving you a small demonstration for eye center. Let us say we are having this coupler link separately. This coupler is, let us say this AB is coupler. At some T point, it is at this position. At some point of time T plus dt, it reaches to new position A dash B dash. Then my dear, this move from A to A dash, this move from B to B dash. So my dear, if you want to find out the eye center, the method is you will sit perpendicular to the direction of motion. Why? Because whenever something is in pure rotation, then velocity direction is perpendicular to the radius. So we are going to sit perpendicular to this A dash. So at this line, wherever you sit, you will find A is in pure rotation. Similarly, my dear, at this green line, wherever you sit, you will find the motion of B to be in pure rotation. So my dear, that's why this intersection point will give the motion of complete AB to be a pure rotation motion. So that is why this point is given the name of eye center, because about this point AB is in pure rotation. And if you pass any axis from this point perpendicular to the plane of board, it is said to be eye axis of rotation. This also I taught in 1 hour in the class. Here I am just completing in 2 minutes. So this is for revision only, guys. Okay. So this is something said to be the how to find out eye center. So for eye center, you need to sit perpendicular to the direction of velocity. Now, my dear, we are talking about number of eye centers in a mechanism. When we are talking about number of eye center, it is given as L into L minus 1 divided by 2. So if we have L number of links, the number of eye center will be L into L minus 1 by 2. Let us say we have 4 links in a mechanism, then 4 into 4 minus 1 divided by 2, it is coming out to be 6. Now, my dear, as there are 4 links, eye center is defined as IMN. This is a point about which the relative motion between link M and N will be a pure rotation motion. So if we are going to define IMN, there are 6 IMN for 4-bar mechanism. One is 1, 2, other is 1, 3, other is 1, 4. Then it is 2, 3 and 2, 4, and then it is 3, 4. So you can see 1, 2, 3, 4, 5, 6. These are 6 eye center. I must show them like I12, I13, but I am not writing I all the times. And my dear, if you have L number of links, then minimum L number of eye centers would be known to us. Okay. So if there are 4 links in a mechanism, then we would be knowing at least 4 eye centers. And generally this entire line is known to us and this is known to us. So out of 6, 4 eye centers are known to us. Other we are going to find out using Kennedy's theorem, because for using eye center approach, we need to apply the Kennedy theorem to find out the unknown eye centers. Okay, so my dear, this is how we are going to move with. So first of all, we must know what are the known eye centers. So if in a mechanism you find any turning pair, in this is link number 1, this is link number 2, then the point at which both the links are connected, this is I12. So about this point, the relative motion of link 1 and 2 is going to be pure rotation. Okay, so this is I12. Second, we are going to have rolling pair. For rolling pair, this point is said to be the eye center. I feel in the classes we have derived in this way that this is the rotation component of velocity, this is translation component, this is resultant velocity, perpendicular to that will give you eye center. This is translation, this is rotation, this is resultant, perpendicular to this will give you eye center. This is how we derive the eye center, how it is coming. Are you remember or not? So this is the case of rolling pair. In sliding pair, we can have 3 type of surface. One is this. Okay, so if we have a slider moving on to this surface, then my dear, their eye center is nothing but the center of this surface. So this is one, this is another. If you have slider like this, then you know that the velocity direction is this, perpendicular to velocity will give you eye center. Here also perpendicular to velocity will give you eye center. So you are getting the eye center at the center of rotation for curvatures, and for plane surface, if you go perpendicular to velocity of 2 points, these are parallel line will meet at infinity. So for this, I12 will be at infinity. So you have seen for sliding pair it is at infinity, for turning pair it is at point of contact, and also at rolling pair it is at point of contact. Moving further, guys, we have seen convex and concave surface. Now we are, okay, this is not required. Okay, now we are going to see eye center approach for one mechanism. I will show you only for one mechanism I will show, and then we will move to the relative velocity approach. Okay, so my dear, when we are talking about this is a simple 4-bar mechanism. If you see, this is OABC. So whenever you see this mechanism, how to solve, you will say the number of links are 4 and the number of eye centers are 6. So if you see number of links are 4, number of eye center will be 6. I have seen with the formula. So if you see, this is link number 1, link number 2, link number 3 and link number 4. You will write all the 6 eye centers. It is 1, 2, 1, 3, 1, 4, 2, 3, 2, 4 and 3, 4. Then you will see all the known eye center, my dear. So you know that this is turning pair. So I will call it as I12. This is turning pair, I will call it as I23. This is turning pair, I will call it as I34. This is turning pair, I will call it as I41. So these are 4 turning pair, 4 eye center we got from here. And these 4 eye centers are known to us. As I already told you, minimum eye centers known are equals to the number of link. We may be knowing more than that, but always that is the minimum number known to us. So guys, we have these 2 unknown eye centers. And to find out that, we are going to use Kennedy's theorem. Okay, what is that? We will be making a circle. In this circle, we will be making a quadrilateral or a polygon which is having the same number of sides, which is equal to the number of links. So 4 number of links will give you quadrilateral. 1, 2, 3, 4. So my dear, if that is the case, 1, 2 is known to us, 2, 3 is known to us, 3, 4 is known to us, 1, 4 is known to us. The first unknown eye center I will be showing 1, 3. If you want to reach from 1 to 3, there are 2 possible paths. One is 1 to 2, 2 to 3. One path is 1 to 2, 2 to 3. And second path is 1 to 4, 4 to 3. 1 to 4, 4 to 3. So these are the two paths, okay, you can follow. So my dear, if these are the two paths we can follow to reach from 1 to 3, you need to extend the line joining these two eye centers, because on that this will also lie. Because Kennedy's theorem is, if we have three links 1, 2 and 3, then from these three links we can have three eye center, 1, 2, 2, 3 and 1, 3. And for relative motion between three, these three must be on a straight line. That is the Kennedy theorem. So this 1, 2 and 2, 3 will be on a line where 1, 3 will also lie. So I will extend the line. We need to find out 1, 3 where it is. Similarly, on these three, eye center will lie on the same line. So 1, 4, 3, 4. We will extend this as well. So when you will extend this, you will get here I13. Okay. So you will get here I13. Once I13 is known, we will go for the same for I24. So when you are going for I24, my dear, there are two paths while going from 2 to 4. One is 2, 1 and 1, 4. Other is 2, 3 and 3, 4. So 2, 1, 1, 4. 2, 1, 1, 4. You will extend this line. Okay. And you will extend this line. Here you will be getting the eye center I24. So this is how we are going to find out the eye center. Guys, please tell me, is it clear or not? So are you getting this revision or not? Please tell me that. Understood or not? Yes, everyone. Fine, very good Shreyas. Midun, बहुत ही बढ़िया. So guys, we have already seen the Kennedy's theorem. Okay. Now we are moving to relative velocity method. Yes, now we are going to relative velocity method. Okay. Before that, I will tell you the theorem of angular velocity. I will not derive it like I have done in the class. I will just write what it is. In the class, I derived it with the turning pair. This is the theorem of angular velocity. Okay. So my dear, this is the theorem of angular velocity. If you know the angular velocity of link number 2, you can find out for link number 3 using this equation. Okay. So this is how we can use theorem of angular velocity. Now we are moving to the relative velocity approach. So my dear, when we are talking about relative velocity approach, what is the logic behind that? The logic behind that is, let us say when we are talking about a link which is having general motion. So general motion means it is having two types of motion. One is translation, other is rotation. So let us say this link AB is having two motion. One is translation, other is rotation. And let us say the velocity of translation is 2 meters per second. I am showing this is 2 meters per second. And let us say the rotation velocity is, you know, it is rotating with some angular velocity omega, and it is starting from 0 linearly, v is equals to r omega, like this. So this is 5, 4, 3, 2, 1, 0, like this. So if you will connect both of them, you will get the velocity value 2 here and 7 here. Okay. So this is the velocity profile. Velocity is increasing from 2 and going to the 7. So you can see this is translation, this is rotation. So what Sir Kennedy said? Sir Kennedy said that if you will be sitting at point A, then your velocity will be 2 meters per second. And you will be looking at B, whose velocity is 7 meters per second. So you tell me, if one person is moving with 7 meters per second and you are moving with 2 meters per second, so according to you, the velocity of other person will be what? According to you, the velocity of other person will be what? If this is A, this is B, what is the velocity of B with respect to A, guys? Yes. What will be the velocity of B with respect to A, guys? Tell me, tell me, tell me. Yes. 5 meters per second. Very good. So it is going to be 5 meters per second. So velocity of B with respect to A will be 5 meters per second. But if you see 5 meter is the velocity due to rotation. So what do you mean by that? In reality, this link is having both translation and rotation. But when you will be sitting at point A, you will get the translational component. So you will be able to see only rotation. So guys, if you are going to see the velocity of one point with respect to other, then you will see only rotation component. So according to you, the motion is going to be pure rotation. That is the relative velocity approach. And here also we are going for graphical approach, where we are going to plot the velocity diagram. So as I said, this is formula revision. I am not going to plot the velocity diagram, but I will show you the two special cases from where the questions are coming. So in relative velocity approach, the first question is coming from this case, where you are going to have perpendicular input and output component, or you can say these two links would be parallel to each other. So if these two links are parallel to each other, my dear, you are going to make the velocity triangle, then O and C are going to be the fixed point, you know that. Then when you will be sitting at O, you will see the velocity of A, it will be perpendicular to the link length, and the magnitude is going to be R into omega, you know that. So you will get to know 10 into 550. So you can write the velocity in this direction. The velocity is in this direction. So I am giving this point name as A. Then my dear, whenever you will be sitting on A, the velocity of B with respect to A is perpendicular to this link. So you will be plotting this, because B point will be coming on to this. But B is not known to us. You will be sitting at C. When you will sit at C, the velocity of B with respect to C is perpendicular to this. So once again, you are going to make a perpendicular line from the C, which is this one. So you were saying B is on this line. Now you are saying B is on this line. So you are going to get B here only. So you can see velocity of B with respect to C and velocity of A with respect to O, both are equal. So in that case, we can write velocity of BC, velocity of AO. This is the question 5 times asked in GATE. So you will be writing BC into omega BC, OA into omega OA, and equating this, you can find out the omega of BC, which is asked in the question. So this is the first type of question coming from relative velocity approach. The second type of question is coming from crank and slotted lever mechanism. This is link 1, this is link 2, this is link 3, and this is link 4. So my dear, whenever we are talking about forward stroke, I am writing the direct formulas here. For forward stroke, omega for maximum is coming out to be equals to R upon R plus L into omega 2. And for return stroke, we are going to have omega for maximum R upon L minus R into omega 2. Okay guys, is it clear to everyone? If you see these two slides, you can solve any question from relative velocity approach. So this is how the formulas are done. Like I have covered the relative velocity chapter in 10 minutes hardly. So this is how the formula session should be. And other chapters we are going to cover like that, because for crash course we are going to have another series in next month. There we are going to teach you all the subjects in detail. Okay. So in formula series, we must only show you the formula. So here, my dear, in acceleration diagram, when we are talking about, you know that when we are having a link which is having rotation motion, why? Because we have converted all the links motion into rotation. Then, my dear, there are some kinds of acceleration which are working. You know, when some body is moving in rotation, then my dear, its direction is always changing throughout. So direction of velocity cannot change without acceleration. So to change this velocity, there is a radial acceleration acting toward the center. Always there is a radial acceleration acting towards the center. And this radial acceleration is given as omega square r. Which means that even if some body is rotating with a constant angular velocity in a circular motion, then also, my dear, it will be an accelerated motion. Means circular motion can never be a uniform velocity motion. It will always be a accelerated motion. Why? Because even if body is rotating with a constant angular velocity, then also its direction is changing all the time. So this radial acceleration will be coming. Now, if you see the magnitude of velocity is also changing from omega 1 to omega 2, then there would be some angular acceleration alpha will also be acting. For that, there is a tangential acceleration AT, which is given as r into alpha. So my dear, when we are talking about radial acceleration, always acts towards the center. Always acts towards the center. And tangential acceleration always acts perpendicular to the link in sense of alpha. Like if alpha is given in this direction, then tangential acceleration will also come in this direction. Is it coming? Is it clear for all of you guys? So if you see both the acceleration, they are perpendicular to each other. If you see the radial and tangential, they are perpendicular to each other. So you will be saying the net acceleration will be radial ka square plus tangential ka square. This is the net acceleration for this case. Is it clear, guys? Is it clear, guys, for everyone? क्या ये सभी लोगों के लिए सही है? अरे बोलो भाई. Mani, Midun, Shiva, Kartikeya, Shreyas, Saurabh. Okay. So shall we continue after this next Saturday, Sunday? We need one session more for TOM and one session more for machine design and vibration. So 2 sessions we will be having more. Is it clear? Is it fine for everyone? On next Saturday, Sunday in the morning, we will keep these 2 sessions. Okay, in the next Saturday, Sunday, we will keep these 2 sessions to complete entire TOM and also the machine design. Is it clear for everyone? Is it clear for everyone? Yes. So goodbye guys for this session. Just join my Telegram channel, Mechanical by Dheeraj Sardana, and there I will be sharing the PDF of this session. Okay. Yes. So goodbye guys and thanks for joining. Thanks for your time. Goodbye.